Bom dia a todos. A apresentação do professor Frederick vai ser em inglês, né? Então, a introdução aqui eu vou fazer em inglês por uma questão de cortesia com ele. Well, Professor Frederick Heinz, who is going to make this presentation here, actually a short of a mini course, towards trustworthy AI integrating reasoning and learning. Professor Heinz is a professor of computer science at Linköping University, where he leads the division of AI and integrated computer systems and the reasoning and learning lab. His research focus is AI, especially trustworthy AI, and the intersection between machine learning and machine reasoning. He is the director of the Wallenberg AI and Transformative Technologies Education Development Program, director of the Graduate School of the Wallenberg AI Autonomous Systems and Software Program, WASP, coordinator of the Taylor ICT 48 network, developing scientific foundations of trustworthy AI, member of the board of ADRA, the AI Data and Robotics Partnership, president of the Swedish AI Society, and fellow of the Royal Swedish Academy of Engineering Sciences. It's a pleasure for me to introduce then Professor Frederick Heinz, who is going to lecture us and teach us some concepts regarding trustworthy AI. Thank you, Frederick.
Good morning, and thank you very much, Carlos, for the introduction. It's always a pleasure. Of course, I would very much have liked to be there on site, but unfortunately that was not possible this time. So basically what I want to do here today is to give kind of an introduction and overview of this trustworthy AI. And of course, also to give a bit of state of the art, what is happening within AI today. And of course, there is a lot of excitement around large language models. So I will, of course, talk about them as well. But the kind of the overarching focus and topic here is today is really how can we, what can be done with AI, but also how do we do this in a way that we maximize the benefits while we minimize the risks and deal with the issues that may occur as part of this. I should say that I have focused to make it relatively non-technical, or well, mostly non-technical. But if you have more technical questions or want to know more about something, please let me know, and I will do my best to dive deeper into something. And maybe this is good for before I kind of go into the topic. I mean the outline. So if I understand correctly, we are going to continue for another 30 minutes or so, and then there was a 10-minute break, and then we resume again at 9 local time, and they'll go for another 50 minutes. So I will talk for about half an hour, and then we'll have a short break, and then we continue. So a little bit more about my background. So I started out as a PhD student building autonomous systems a little bit more than 20 years ago. So actually we have more than 20 years of experience of building fielded AI systems. So we start out with this helicopter that you see in the middle, but we've also been very much involved in RoboCup with the goal of building soccer-playing robots that can beat the human world champions in a real soccer game, and to do that on the human condition. And we're also very much working in this public safety area, where we also have a lot of collaborations with you in Brazil. So we are very happy and fortunate to have this collaboration with you. And so basically what we wanted to do from the beginning was how do we build collaborative unmanned aircraft systems? So basically a principled approach to building these collaborative, intelligent, autonomous systems for complex missions. So we are actually developed both physical platforms. So actually all the platforms to the left, top left and bottom left, are systems that we built ourselves. So And actually, this was more than 20 years ago, so it's been quite a while. And then the larger helicopter up to the right is a Yamaha Armax, so it's about 100-kilo system, which we then made completely autonomous. And in some sense, what we learned from this was really to build integrated computer systems. So that's why the division which I lead is called AI in Integrated Computer Systems, because our main research focus is on AI, artificial intelligence, but we do apply it by integrating it into physical systems. And actually, one of the main results of this was really an architecture. How do you combine many different AI technologies into working systems? And how do you make them actually fly and do real missions? So this is a little bit about my background. Today, as Carlos mentioned, I also lead the Reasoning and Learning Lab. So this is one of the units within this division. And our focus is very much on how can we combine techniques coming from more automated reasoning, so kind of knowledge representation, more logical approaches, more formal guarantees, together with machine learning, where you get to adapt to the environment by collecting data and by interacting with the environment to improve your performance over time. So we start out more in this kind of knowledge representation area. We move towards machine learning. We also do quite a lot of work in multi-agent systems, and we have multiple of these agents working together. And we're especially interested in these intersections between these different areas. For example, how can you use machine learning to scale up reasoning, or how can you do machine learning which actually is logically coherent and consistent, and so on and so forth. So we're working with a broad range of different techniques from these different areas. So we're actually quite a broad and diverse group working on many different aspects. So this is just to give a very brief background to some of the work to some of the areas where we work. So now let's get into where are we today. And I think it's quite interesting that AI, I would argue, is here now, and development is very rapid. With this, I mean that basically every one of us are using AI on, if not a daily basis, probably close to it. We're using recommendation systems to select what movies to see or music to listen to. We use automated translation tools to translate between different languages. We use voice to control our different devices. But at the same time, we see that the development is very, very rapid. And I would argue that AI will affect all aspects of society. So this would really have this broad impact on society. And the reason is that AI is what we call a general purpose technology, meaning that this is a technology which is not only a technology of itself, but also a technology which changes or influences all other technologies and opens up completely new possibilities. I think that one of the key challenges, if you want to work with AI, is that you need to focus on data infrastructure and leadership. That we really need to build up the appropriate infrastructure and set up the appropriate data flow within the organization to really take advantage of AI. The second part is leadership. I think that, of course, there are many qualified and very capable people within your organizations, but it's also very important that you show it from a leadership perspective that, yes, this is important for us as an organization, and then providing the mandate and the possibilities for people within the organization to help make this a reality. So these are really key components in successful use of this technology. I'm also strongly convinced that AI should be human-centered and trustworthy. And what we mean by this is that AI is not a goal in itself, but rather a means to help us as individuals and as organizations and as a society. And that in order for this to really take effect, it's important that people, the individuals, and organizations, of course, also feel that they can trust this technology. And that's why I argue that it should be trustworthy. So it should be technology that is worthy of our trust. And in some sense, that's what we want to cover in this talk. And last but definitely not least, I do not believe that AI will take over the world and make humans obsolete. But I do believe that people that effectively use AI will outcompete those that don't. So therefore, I would argue that I don't think this is something you can just wait and see. But I really think, and we're seeing more and more evidence of that if you're using this AI, already existing AI technology, there is so much you as an organization and also as individuals to gain, so that if you don't do it, you risk being outcompeted. And related to this is also that this is not a question of either AI or humans, but rather it's about AI and humans together. So this is what I will be talking about. And I think the first part is, of course, AI is here now, but I think it's also interesting to see that how the kind of main areas of AI or the most fascinating applications have evolved over time. So when I started to give more public talks like this about 10 years ago, actually probably a little bit more, then the big hype was around self-driving cars. And then the claim was that around 2025, that is pretty soon, we would have these huge fleets of autonomous vehicles, and basically most human-driven vehicles would be replaced. Even though we have seen huge and very impressive progress in self-driving cars, and of course they do exist and they do drive around among us, it's still the case that we're quite far away from this vision of replacing all the human-driven vehicles. So I think this is an example where there was very, very impressive progress in a relatively short time, but then there was also this ceiling that was hard to really get the large-scale adaptation, and it turned out that the problems actually were harder than was originally anticipated. And actually, I wouldn't be surprised if we will see the same development, for example, when it comes to these large language models like ChatGPT and so on, that we will see that they in a relatively short time make super impressive progress, but then that this progress will kind of flatten out because they will hit the ceiling. But we'll get back to that later. The second really impressive application that came was when Google DeepMind beat the human world champions in Go. And this, because the Go was one of these games where it was believed that basically computers would never beat humans, or at least not within the foreseeable future, because Go was a game which was more based on kind of aesthetics and the visual impression, and more the kind of, it was described in more subjective terms. While, for example, chess, there was very clear how to evaluate a board and to see whether is this a good or bad chessboard or good positions for my team, so to speak. But then they showed that relatively quickly they could then beat the human champions in Go. And then based on the same types of techniques, so a combination of this kind of deep learning together with reinforcement learning, they were able to learn to play this game. And at the end, they even did it without any human knowledge. So basically, just by playing against itself.
E o MCTI, para que a gente possa caminhar na busca dessa grande estratégia para o país. E o primeiro documento vai viabilizar isso, que a doutora Márcia acabou de mostrar. Está em minuta, né? Nós estamos construindo ali o texto, mas nós não temos dúvidas que isso será o pontapé inicial para que a gente possa efetivamente criar esse marco de como conduzir essas pesquisas em âmbito nacional. E com quem tem que estar ali, que é o MCTI, que vai capitanear todo esse esforço, né, de pesquisa e desenvolvimento.
Hello, so what's happening? I heard someone else talk. Should I continue?
Painel que nós estamos conduzindo aqui no nível político estratégico, alguns aspectos.
Hello, Professor. Can you hear us?
A defesa,
Yes.
We just had some problems with the microphone here, but in this room, no one's talking. It's other room sound. So
Okay.
you can go on, please.
Because I have someone else talking, which is kind of...
Mas amanhã nós vamos continuar também com o painel.
Oh, maybe I managed to mute them now. Apologies for that. So someone else started to talk while I was here. I apologize for that. So yes, so we had this computer beating the best humans in these different games. So basically having this superhuman performance in a wide range of games, including chess and Go, and now also StarCraft, Dota, Jeopardy, and so on and so forth. We saw that in a wide range of games, the computer was significantly better than the best humans. Then the last, or say, year and a half, there has been a lot of focus on this generative AI, where you have the computer generating content. For example, the DALL-E, or actually DALL-E 2, which came out, I think, early April 2022, really kind of started this trend, which its ability from a small text prompt being able to generate photorealistic images, such as the image here on these teddy bears. So basically you have a prompt, something like along the lines of two teddy bears playing mad scientists dressed up as cyberpunks. And then the computer generate this photorealistic and very, interesting, and also, I would argue, artistic image. We also see now that in more and more applications, you get something called a co-pilot, where you basically get an assistant that helps you do your work or work with that particular application. So the first example here is from GitHub, where they developed this GitHub Copilot, which basically helped you to do programming. So while you were doing programming, it could then look at your code, suggest here are improvements you can make, or are you actually trying to do the following? And here is the code for doing that. So that you really got a very able coworker to help you solve your problems. And what the next step is, for example, Microsoft is now introducing Copilot into Windows. So basically, what we can expect to see is a support tool, a Copilot, to help you with everything related to Windows and Microsoft Office. So I expect this will be the kind of short-term trend that we'll see more and more of these assistants helping people to be more productive in using these different tools. Another perspective is to look at different cognitive functionalities, where you see how the computer in a relatively short period of time is going from not being particularly good to surpassing what we as humans can do, basically achieving superhuman performance in different areas. So we see that, for example, in handwriting recognition, speech recognition, image recognition, reading comprehensive, And here it says language understanding. I would not really agree with understanding, but at least that it's extremely competent when it comes to being able to summarize or shorten or expand or answer questions related to text in natural language. And we see that this has all, to a very large degree, happened in a very short time period. And what we are seeing is really this explosion in capability of these AI-based systems. Before I continue, I would like to take a step back and talk about games again. And the game I want to talk about here is chess. And chess is one of those games where we as humans don't have a chance against the machine. And actually, even the best of humans haven't had a chance against the computer since at least 1997, when Garry Kasparov lost against IBM Deep Blue. But the interesting thing is that the human interest in chess has never been higher than it is today. And we also see that the human competence, the human quality of playing chess has again not been higher. So we can really see that by training against these computer players, we humans become much better. And someone even argues that the reason that Magnus Carlsen is one of the best chess players alive is because he is the human which is capable of playing the most like a machine or a computer, and therefore he's one of the best. At the same time, if you form teams consisting of both humans and chess-playing machines or chess computers, then they actually are better than both the best humans and the best chess computers. So what's really interesting here is that it seems to be that it's not really a question of either AI or humans, but really it's a question of AI and humans together. And that forming these AI-human teams is then significantly better than each on their own. And actually, these contests were done by Garry Kasparov himself. So after he lost against IBM Deep Blue, he was really upset and unhappy. But then I guess he realized that, well, there's no chance in competing. So therefore, he started to create his own chess-playing computer programs, and he also arranged this hybrid AI-human competitions, and came to the conclusion that humans are still superior when it comes to more strategic thinking, while the more tactical thinking, so that given that you want to achieve a particular goal, then the computer is much better than we are at that. But then to choose which goal to focus on, that we are still better at. So I think there are a number of very important and interesting consequences of this. The first, of course, being that it's a combination of AI and humans that is the most appropriate, but it's also that it's a different skill to play chess with the computer compared to playing chess without the computer, which means that you don't necessarily have to be a grandmaster, but you have to be pretty good at chess. But more importantly, you need to know how do you effectively use these chess-playing computer programs to play the game better yourself. So it's really a question of competence development. It's also a question of organization. How do you organize yourself and change your business or activities so that they actually can take these tools, effectively use these tools? And an example I often use here is actually the digitalization of the Swedish school, where there are about 10, 15 years ago, they kind of introduced computers and a broad front into the Swedish schools. And then they actually did a study on this, and they came to the conclusion that in those classrooms, which you just introduced a computer, you didn't really change anything, you actually got worse results compared to if you did nothing. But in those classrooms, where the teacher adapted the pedagogy, adapted how they were actually teaching to the kids, by taking advantage of the computer that now was available, they of course got significantly better results. So the consequence of this is that it doesn't help if you have the best possible tool, you have the best possible expert, and just put them together. You really have to learn how to effectively use these tools, and you need to adapt your processes and the way of working to take advantage of this. So really, this is very much about developing the kind of business or the ways of working, not only a technical question. And of course, so I mean, this in some sense was a general introduction. Now I think I wanted to talk about these large language models and especially ChatGPT for the simple reason that I think it captures the human's imagination, and it's also the application where we see that there's a huge, it really kind of broadens the interest in AI technology. So ChatGPT was, I mean, actually it's version 3.5 that was released in November last year. And it has what I usually call the best possible user interface. It's just a text box. And you can put in anything you want into this text box and the system will respond. And you basically have a dialogue around different topics, and it provides meaningful and hopefully correct input to your discussion. And I think it's quite fascinating about the range of different things that these systems can actually talk about. So you can ask it anything from explain quantum computing in simple terms, so basically asking it questions about science and how the world works, to how do I get some creative ideas for a 10-year-old's birthday. So now it's more, what should we have kind of fun and games? Or you can use it for helping you to do programming. You can ask it questions about, for example, how do I make an HTTP request in JavaScript? And actually, I think programming is an interesting example where basically since programming is text, it means that these kind of language models actually are capable of both generating programming code, but also to have a dialogue around this programming code. And actually, I think there's been very impressive usages. For example, you can use it to do debugging. So you see, maybe you have a text also, this is what the program should do. This is the program itself. Here is the error messages. And then you can ask it, oh, can you please help me find what's wrong? And then you can have a dialogue around your program, and it will help you identify what the possible bugs are and maybe even how to fix these bugs. You can also use it to translate not only between different human languages, but also between programming languages. So for example, you can say, I have this Python program, can you please translate this into a C++ program, or the other way around? So I think that one of the really appealing things of ChatGPT is this versatility and generality, that it's able to have these dialogues. So it's quite fascinating. And then, of course, there are a number of, consequences related to this. And one of the consequences, interesting, aspects to look into is how does this affect education? And you probably have heard a lot of discussions around this with students cheating using ChatGPT to do their homework. And this has actually been studied in some, more organized fashion. And this is then an example, this particular slide is then an example from a British bar exam. So basically this lawyer education, and then they checked how good was GPT-4 on answering the questions on the exams that these students have. And then they came to the conclusion that ChatGPT or GPT-4 is better than the average student on this particular program. And I think this is quite interesting because we have to remember that this is probably a very selective education program, which means that the people that are taking this program are very competent people in general. And then GPT-4 was still better than the average student on this program. And of course, the question then becomes, what does this mean? What are the consequences of that? And I think one to me, the kind of short-term consequence of this is that we need to rethink how we do examination. Because it's quite clear here that even though GPT-4 is better than the average student, I think very few, if any, company or organization would hire GPT-4 as their lawyer, which means that there are obviously other things that the human lawyers know and can do that these systems cannot do. So I really think there is something which we value in employees, but that we do not kind of test as part of their education. So I think that's one observation. And then I think also that how we examine and what we examine, I think that will change, at least in the short term, and definitely in the short term. I think in the long term, we need to think about what should our education programs contain so that we complement rather than we try to compete with, for example, ChatGPT in solving these kind of questions. So what are some of the differences? So I think it's quite convenient or appropriate to compare to pocket calculators. So, the pocket calculators came, 70s, and then there was a lot of discussions, should we allow the pocket calculators into the education or not? And today, as far as I know, they're generally used. And we see, of course, that even though you have a pocket calculator that can do a lot of things for you, there's still a value in understanding and being able to do arithmetic and these kind of things on your own. And there are a number of reasons. One reason is that usually it's too slow if you have to pull up the pocket calculator and do every little calculation. So you need to know what's 3 times 4. Oh, you have to look it up. Then you become very slow. But I think more importantly is like if you want to progress to more complex mathematical concepts, then you still need to know the basics. So therefore, in order to progress, you still need to know the basics. But of course, we still use the calculator to do the actual calculations because it's more accurate and less chance of errors. And I think we will see the same effect when it comes to these large language models. So I expect that these tools will be used, in everyday use, they will be used all the time. So I think we will be using them in basically every or at least very many situations. But I still think there is a value in being able to produce texts on your own, because that's also a way of structuring your thinking and a way of expressing yourself that is still necessary and valuable. So I think there are many different interesting aspects when it comes to impact on these large language models on education. But there's also this question, how good are they really? Because there was this kind of infamous, maybe I should say, study stating that basically these large language models now could pass all the exams at MIT in Boston. But then some of the students, I think actually they were at MIT, they started to look into how was this evaluation actually done. And it turned out that basically they were asking the same question over and over, and that there was a lot of what you would say, maybe not cheating, but at least a lot of help provided by the users in order to be able to actually answer these questions. So therefore, even though you see that the ChatGPT seems to be very competent, I still think that it's because our evaluation and our benchmarks is probably not as good as we want them to be. At the same time, I think we shouldn't underestimate the quality of these systems. So this was a very recent study done at Wharton School of Economics, where they compared business ideas generated by their MBA students compared to business ideas generated by ChatGPT. And basically what they did was that they let the students write their business ideas, and then they used the prompt to generate business ideas for ChatGPT. They gave all of these business ideas to human investors, then had to pick out what are the most promising business ideas, what are the ideas that they would be willing to invest in. And the conclusion was that, if I remember correctly, I think it was 35 out of the top 40 business proposals or business ideas that the investors chose. 35 out of the 40 were then generated by ChatGPT. So I think that the point here is that even though there are, of course, many problems and issues, it's still the fact that it can generate something that we actually value and that we think is good. So it's not trivial and it's not uninteresting, but the other way around. So then, of course, there is this interesting question of how does ChatGPT work? And you can ask yourself, why is this important? And I think it's important because if you understand how it works, then you can also understand why it makes the mistakes it does and why we have the kind of, why we see this kind of different unintended side effects. So in the bottom, or the kind of foundation, is these GPT models. So when ChatGPT or 3.5 came out in November, they used GPT-3 as the basis. Now they're using GPT-4. But what this basically is, first of all, GPT stands for General Pre-trained Transformer. And this then explains in some sense how this model works. It's general, which means that it's trained on a wide variety of different text sources. It's pre-trained in the sense that you train it in advance and you build this model. And this model is then based on transformers, which is one particular technique within deep learning. So it's a particular way of structuring these neural networks, and then you train it on a wide range of kind of general text. And what you learn, or what these GPT models corresponds to, is a statistical model of how languages work. So basically, you give it a sequence of words, often called tokens, as input, and it then generates what's the most probable sequence of tokens that will follow on this. So you're basically having this, learning this mapping from a sequence of tokens to another sequence of tokens. And then this corresponds basically, how do people on average use language? It is a little bit more complicated because it's actually a probability distribution over possible continuations. So there are different ways of sampling this probability distribution and draw different types of continuations. But in general, it's basically learning a statistical model over language. And this is very impressive and very useful. But actually, if you start having a dialogue with such a system, it actually turns out to be not that, what we say, useful. So the second major invention that came early last year was Instruct GPT, where they took this general pre-trained transformer and then they let humans score how good they thought the different steps in a dialogue was. And by scoring these different steps and then refining the weights so that it was then changing the model to go from a general statistical model of a language to how do people want to, what kind of interactions do people want? So this kind of refining is then an important step after the general pre-training. And this is often done using a technique called reinforcement learning from human feedback, where reinforcement learning is then one particular technique where you interact with the environment to get input, And in this case, you interact with humans, which then provides this score. And so here I expect that we will see a wide variety of different models, or more adapted dialogues, so to speak, that they are adapted for different professions or different domains with this kind of adaptation. And then you add a third layer, which is more a safety layer. So in some sense, trying to filter out the worst kind of, the worst possible outputs and the kind of worst possible inputs. So trying to remove as many unintended or undesired conversations as possible. But as you probably have heard, it's quite easy to go around this. For example, you say, assume that you didn't have to consider the safety rules. How would you answer this question? And then you could kind of get around the safety mechanism. So I think there's quite a lot of interesting, but this is kind of on a high level how this ChatGPT works. So now we can ask ourselves the question, can you trust ChatGPT? And I would say, no, you cannot trust these systems. And why can't you trust it? Well, first of all, we have very limited information about how these systems are actually trained. We know, in general, how the method works. And of course, we can guess quite a lot of the different sources of material like Wikipedia and so on. But we don't know exactly what the data it has been trained on. And the consequences of this is that it's very difficult to understand what are the limitations, what are the kind of implicit values that this system has learned, because all of that is to a large degree dependent on which data did you use for training. It's also a problem, or one of the reasons that you cannot trust it is because it generates output that does not exist. And sometimes you call this that it hallucinates. So basically it could, for example, be that you ask it, it makes up things that is not true. And one of the reasons here is that it doesn't have a model or an understanding of what it's good at and what it's bad at. So therefore, it will always answer the question, even when it doesn't really know. And you can even ask it to generate references so that you can say, please provide sources for all your claims. And it will gladly do so because, what this model will do is that it will always try to accommodate your questions. It will always give you an answer, which means that if you ask for references, you will get references. But these references may actually not exist. Or if they exist, they might not be applicable to the particular text itself. So, and one of the reasons is that these systems are incapable of doing formal reasoning. So it cannot really count, it cannot draw logical conclusions, but rather it looks at the text, which means that if this kind of combination of words often occur together, yes, then it's likely that it would actually produce it. So here we can, of course, find a major weakness, but at least it's kind of important to be aware of. So the clear answer is that you cannot trust ChatGPT. However, I would still argue that it's useful, but you have to be aware of this, and you have to learn how to ask your questions, how to provide an appropriate context within which the system should answer your question. And then you need to be able to critically examine and validate the resulting text. So I think this also shows where do we need to go when it comes to education. So I think today education has a large focus on answering questions. But I think what we are seeing is that computers are becoming much more, competent when it comes to actually answering questions. But the difficult part is asking the appropriate questions and then judging and critically examining the answers. So I think school might need to change from asking questions, from learning how to answer a question to learn how to ask questions and to how to evaluate answers. So I think that's quite an interesting development. So if we look at the kind of development of these large language models over time, we see that they're basically following this exponential development, because this is then a log linear graph. So it's a linear scale on the x-axis with the years, but then it's an exponential scale on the y-axis. So basically, if you have a linear trend here, it means it's actually exponential in the number of parameters. And the number of parameters then corresponds to the number of weights in these very large neural networks, which then represents these language models. But there is also a very interesting aspect that there seems to be a relationship between the size of the model, so the number of parameters that you can actually train as part of the training, you can change them, the amount of compute that you have available, and the amount of data that you train these large language models on. So here, I mean, basically this graph here shows that if you kind of fix the amount of compute time that you have, and you fix the amount of training data, depending on the size of the model, you get different types of behavior. So basically, if you want to improve the quality, the accuracy, for example, of your large language models, it's not enough just to add, for example, more parameters or just add more compute or more data, but rather there is a relationship between the amount of parameters, the amount of compute, and the amount of training data that you have. So that if two of these are fixed, then you can basically find the optimal value for the third. So this is in some sense what's shown to the left, where you see that first of all, you as you increase the model size, you get better and better performance. But then when you start increasing the model size even further, then it actually becomes worse, for the simple reason that just not enough training data and not enough compute. So I think this is important to keep in mind. And actually, we have recently been awarded a new European research project called Trust LLM. So I will be coordinating this project where we will develop more factual and more trustworthy large language models. And basically, we will work with the whole kind of pipeline from data creation, model pre-training, model alignment, and model transfer, and so on, to really develop this large-scale training framework, including, and then, of course, fine-tuning afterwards to make models that are more factual and that we can also trust. We're also very much interested in supporting an open ecosystem around these large language models, and most likely we will also focusing on open sourcing as much of both the data, the pipeline, and potentially also the models that we train. And we will do this initially on the kind of Germanic languages, but the intention is to learn how to do this so that we can also do it for low resource languages and to scale it up to as many languages as possible. So this project will officially start, I think, probably 1st of November, as we're currently in the startup phase. So what's the next step when it comes to large language models? So, I mean, somewhat in relation to the previous slide, I really think that one of the key steps is to how to make large language models more factual, coherent, and trustworthy. I also think that, I mean, now there is a major issue in that they're so data and compute hungry. So the question is, can we find better ways of training these, or better models for that matter, which can get the same kind of quality, but with less data and with less compute, and this both at a training and inference time. So there is a lot of interesting work in, for example, how can we compress these models so we can remove nodes and weights and so on. So you get a smaller model, but with the same kind of accuracy, or at least not significantly reduced accuracy, as one example. There is also, for example, quantization, where instead of using like double precision floating point numbers, maybe you're only using 2-bit numbers or something very, very coarse weights, but still you're able to get most of the performance anyway. I also expect that we will see more modular and more specialized large language models for different domains and different usages. And actually this making these more modular is actually one of the other research challenges that we are addressing in Trust LLM. So my expectation is that we will see a large variety of different language models. We are already seeing this multimodal large language models. So I think OpenAI announced, I think it was yesterday, that now ChatGPT can both hear and see, so that it can start to take input both visually and auditory and textual. And the next step is, of course, being able to generate and produce multimodal output. So, for example, can you generate a interactive presentation with text, with images, with sound, and so on? I mean, that would, of course, be both impressive and useful. And I mean, that's what I expect to be the next step. And my expectation when it comes to these large language models is that I think we will use them as a new and generic interface to large amounts of data or information. So, I mean, you can imagine, for example, a city or a country or an organization. I mean, each of our organizations have tons and tons of documents that very few people read. But still there is valuable information in them. So if you train your model on all the different documents that you have in your organization, then you will get a generic interface. Now you can start asking questions. So what are the 3 top most important documents for this question? Or summarize all the documents related to, I don't know, recruitment. Or you can have this kind of dialogue around the particular documents, the particular information from your organization. So my expectation is that this will be very commonplace in relatively short time. So, and I mean, in general, I think there are basically infinitely many possible applications for these large language models. And the reason is that basically everything in our society is very much related to language and to text. Therefore, these very generic approaches then provides this opportunity, or kind of opens up all these possibilities for large language models to work on this kind of textual information. So actually, I mean, I expect large language models to play a major role in most future applications. So I've now been speaking for close to an hour. So maybe this is a good point in taking a break. And also, if there are any questions, I would be more than happy to answer them. Does that sound like a reasonable thing? I mean, I don't see anything about you, but for those of you who are in the room.
So let's thank Frederick.
Maybe you already left.
Frederick, is Philip here? Oh, I now you see me probably. I think we do not need a break, so we can. Is that okay for you, Frederick? If we go ahead for the questions, to the questions? Are you there? Frederick? Can you hear me? I don't think he can hear me. Now, Frederick, can you hear me?
Yes.
Oh, Did you hear me before? I don't think so, right? Oh.
No, because I had to mute this channel because there was chat on it before.
Okay. I was talking that I think we do not need a break right now. I think we can go ahead to the questions. Is that all right?
Yeah, I'm happy to take questions, or I can continue.
And I thanked you, so I think we can go ahead to the questions. So, anyone has questions?
Hello, Professor Frederick. First of all, congratulations for your presentation and your research in this area. And my question is related to the dilemma, define what's trustworthy in this area, because once we have several data to training these LLM models, once we have the human have bias on these in production of your data, how to handle with the paradox to avoid transfer this bias to the models?
Yes, so this is a great question. So let me see. So yeah, so I think there are a number of different aspects here. I think the first aspect is that you're absolutely right that the data that we have, basically the biases and so on that is in the data, will influence the resulting model. Therefore, the first step is, of course, how do we curate and collect appropriate data sets, which has as little bias as possible. But then, of course, there's also steps you can take in the training process itself to reduce bias. So, for example, actually, we have done some research on exactly this, where we are, for example, taking certain aspects. I mean, maybe there is gender or religion or kind of these things that you don't want to influence the outcome. Then you can train your model by basically reducing the statistical dependence between the model and the sensitive attributes. So we use mutual information as the concept, I mean, the kind of statistical concept, and then we reduce the mutual information between the model and the sensitive parameters. And then we can get, I mean, that's one way of dealing with certain types of biases. There are many others. So there is a whole field in basically trying to develop machine learning methods that can reduce the bias in the resulting data. But yes, it's very important, and it's an unsolved problem. And I think it will be a long-term and continually evolving process of dealing with this.
Okay, thank you.
Thank you, Professor Frederick. Regarding this question, on the other hand, we are trying to do a large language model more factual, more specific, but in the UAV case, we need LLMs more ethical. In this case, we need a bias for LLM for target purpose, for decision-making process autonomously for UAV. How can you see the challenge in this matter?
So let me see if I managed to interpret the questions. I mean, I mean, from what I understand, you're more focusing on decision making, and you're focusing on decision making closer to, say, autonomous vehicles, and that they need to make decisions that are kind of ethical. So I think, first of all, I think that, I mean, the ethical part we as humans need to provide. I don't think, I mean, I don't think the systems themselves are ethical or unethical, because I don't think they can make this kind of more moral judgments or moral-based decisions, but it's rather a question of how do we either train them. So basically, when we train these systems, we use our own kind of ethical values and ethical compass and so on when we train the system. So we transfer, in some sense, what we want the systems to do. And the same if you're using a more kind of rule-based approach. Again, I would say that we write the rules, and these rules then encode what kind of ethical considerations we want to have done, and then the system basically carries this out. So I would argue that it's we, the designers, the engineers, the people building these systems, we are the ones that needs to be ethical. We are the ones that need to make these ethical considerations, and then we have to make sure that the systems we build do not kind of violate what we want them to do, which of course is an important part of how do you do this kind of verification and validation of systems, especially if there is a learning component in it. And again, I would argue that this is very active research areas, but there is, I mean, it's not done, and I don't think it will be done anytime soon, but rather we will continually improve and make better systems that are more robust and better at making the appropriate decisions.
Thank you. Anyone else? Here.
Thank you, Professor Heinz. Until, well, not probably recently, but we have always heard about the Turing test as a kind of a gold standard for evaluating AI, but recently I've read about a lot of people talking about the limitations of these kinds of tests. So, and naturally we need to be able to have accurate measures to measure how well the AI systems can relate to well, whatever goals we need to them. So do you have can you give a brief overview on how we measure the measurement systems, and we can improve our way to measure these models, so we can have them move towards the goals we want them to?
So again, this is an excellent question. So I think there are many different aspects again to it. I think a first aspect is if we want to use, I mean, the question is in some sense, how do you measure intelligence and how do you validate these kind of measurements? We can take something as IQ tests, and I'm sure many of you either have done them or at least seen them. You basically have, for example, this kind of geometrical pattern, and you see a number of examples, and then you need to know what is the logical next step in this sequence. And that type of IQ tests is something that's basically trivial for a computer, because a computer is extremely good at detecting these kind of patterns and then generating, or answering the question. So first observation is, if you want to use these IQ tests to measure intelligence, then we have to accept that basically the computer is much more intelligent than we are in this respect. I think that most people would agree that this is probably not what we really are out after. So of course, the Turing test, where you basically have a human interacting with two different systems. So it's interacting with two, individuals. And basically one individual could be a computer and one individual should be a human. And now the question for the human interlocutor is to determine which of the two is the human and which of the two is the computer. And this is, a simplified version of the Turing test. And my problem with this is really that it's more about being human-like than to be intelligent. And of course, there are already today systems that would, fool, or whatever you want to call it, most people. And I would say that if you look at, rather than having this kind of interactive dialogue, but rather looking at content, I would say that today it's very difficult to determine whether a text or an image or a piece of music or something like that is done by a computer or done by humans. So this kind of imitation game, I think it's clear again that the computer is as good as we are in this imitation game. So the question then becomes, what should we use instead, or what is the next step? And here, I think my perspective is much more application-oriented, because I have this kind of instrumental view that, I mean, we are building tools, we're building systems that help us solve difficult problems. So therefore, the way that we evaluate these and the way that we kind of measure the quality has to be dependent on the application or the domain. And at the same time, of course, we want to make them more general. So, I mean, I would say today it's possible, to build even physical systems, robotic systems that are capable of solving reasonably well-defined and well kind of delimited tasks. But what's missing is generality, being able to solve a wide variety of different, achieve a wide variety of tasks, and robustness, so that if there are too much deviations from the kind of what they've been evaluated on or tested on, then they have a tendency to break down. So, and what we see now with these, for example, large language models, is that they're becoming much more general. So in some sense, dealing with this more general kind of interactions, but we still have the robustness problem that even though it can answer any question you give it, but the quality of the answer and the robustness of this answer may vary. And to just give another example of this, is that if you ask the same question in different languages, you will get different answers. So actually one way, at least 2 languages. So you can ask the same question in 2 different languages and see how it responds as one example. So there is very little robustness. And here, of course, it's the ways of measuring this is through interaction, but also through more systematic testing of a wide variety of different settings or usages of it. But I completely agree with you that measuring and quantifying, all these different aspects like accuracy and generality and robustness is very large and open questions, and that's even without considering the broader question of how do we define suitable metrics for intelligence, and how do we actually evaluate how intelligent these systems are. So I think there again, this is just we have just seen the beginning. There is much more work to be done.
Thank you. Anyone else?
Professor, you said that AI is not full trustworthy nowadays. But do you think that AI someday in the future will be full trustworthy, or not full trustworthy, but as trustworthy as a big specialist in an area? For example, do you think AI one day will can answer, for example, your questions that you answer now, the same way you answer, or even better? Do you think AI will achieve that one day?
Yes. And honestly, I don't think the distance is that far. I think within relatively limited domains, I'm absolutely certain that these systems are better than we are. Of course, we still have this kind of generality aspect where we are capable of doing much more, but I expect that to go away. When it comes to quality, I definitely think we will see significant improvements, and I think we will see rapid improvement. The next couple of years. When it comes to trustworthiness, I think that's a much more interesting question. And actually, I think we will see trustworthiness I think there will be both an overconfidence and an underconfidence. So in some sense, I think there will be cases where we trust the system too much, and there will be situations where we don't trust it enough compared to what it's, in some sense, would be worth trusting. And I mean, my expectation is that we will interact with these AI systems very much like we interact with people. In the sense that, I mean, if you have a new colleague or a new employee or something like that, in the beginning, you probably will monitor the work or the work that this person is doing much more closely. And then over time, you will build up a confidence in, this person, he or she is very capable of doing these things. And then as long as that person is keeping doing similar things, you will trust them to do it well. But then maybe one day, now it's time for you to do something more challenging. And then you give them a new kind of task. They maybe have to do something more complex than they have done before. Then again, you probably, okay, now I need to monitor the progress until you can trust them. And probably you will trust them quicker for every time, because, I mean, if you trust them so far, they have done a good job, then you can trust them to do a good job also on these more complex tasks. So I think we will learn to trust, or to, and if you want to put that in some sense in a kind of more machine learning terms, I think what we will learn is for what types of questions or what types of domains will this model do good things, and for what type of domains or questions will it do a poor job. So you're basically understanding the limitations of the model, and when you understand the limitations of the model, then you know what you can use it for. Of course, what's very interesting and what is a very active research area is basically modeling the uncertainty of the model itself. So, I mean, one of the issues with these large language models is very much that they're super confident, and it doesn't matter if they know exactly what the answer is or if they're just making an arbitrary guess, because from the model's perspective, they're always producing the most likely output. So there is no real difference in its how certain it is about the answer. But if it then would actually learn that, I know everything, I don't know about the Middle Ages. So if you ask me about the Middle Ages, I know everything. I have all the information. But there's this new kind, I don't know, space travel or whatever. And there's some area where I know little, and then I should answer with less confidence. So if you have this explicit modeling of what areas or what topics or so on that you're confident in and what areas you're less confident in, you can adapt your answers the way that we humans do. We say that, I'm not sure about that, but maybe it's like this. Or if you definitely know the answer, it's definitely this way. Then we have this, we kind of moderate, or we modulate our answers depending on how certain we are. And it would be interesting to see if we can build this into this model. So I haven't really seen any work on that, but I expect that probably that will be something that can come later. So definitely, I do think we will see what you ask for.
Thank you.
Anyone else?
So I mean, just first, I mean, actually, I have more presentations, so maybe I can continue, and then because I think these questions were absolutely great. So I really enjoyed taking those questions. But actually, some of these questions I have some input on further on in the presentation.
Okay, I think that works. Okay, you can go ahead and.
So just a kind of practical question. So we are supposed to end at in 20 minutes, right?
Yes, 20 more minutes. Is that enough, Frederick?
I will adapt.
Okay.
I'm human. I can adapt.
You can go ahead.
Thank you. So I will now skip quite a number of slides and then jump into some parts. So I had some more how this actually works from a technical perspective. But actually, I wanted to talk about this because you asked about decision making. And actually, I think one of the major usages of these tools is to improve human decision making. So if you work as, for example, a medical doctor, then you're supposed to base your medical decisions on the best available information. And what we see is that we see an exponential growth in the types of information that is available, but we see that our cognitive capabilities are basically the same, which means that there is a growing gap between what we could consider when we make decisions and what we're cognitively capable of. And of course, I mean, there are many ways of dealing with this. One way of dealing it is specialization, but the second one is how can we use tools? So what my point here is that I think we really need to use these kind of tools if we want to make the best possible decisions. I think this is also very much related to competence, so that if we want to have the latest and best knowledge, then again, we really need to use these kind of tools. We mentioned this with bias. So, I mean, I think you're all aware of challenges of bias. And I think there are kind of two different types of biases. One type of bias is when the data that you use to train your models do not represent the world. In that case, because, I mean, the data is poor, then you just need to collect more data. You need to collect higher quality data. But in some sense, it's more a question of collecting more and better data. But another type of bias is when the world is biased in itself. So, for example, we have a kind of salary bias, so that mainly male-dominated types of work, they have a higher salary in general than typically female-dominated jobs. So, of course, then it doesn't matter to collect more data, but we need other types of methods to deal with this kind of bias. I think another challenge is that in order to use this kind of AI and machine learning in real applications, there's actually a lot of other functionalities that we need. So you need to be able to manage and run this kind of large data collection and computing infrastructure, and you need to integrate the kind of AI part or the machine learning part into this bigger picture. And actually, I see this as a challenge for many companies and organizations, is that they're very capable in the kind of AI part, but they lack the competence of managing large computing systems, and therefore it becomes challenging to actually deal with this for real. So, as I mentioned in the introduction, data infrastructure and appropriate computing infrastructure is key to be able to succeed with AI machine learning. I think a very interesting question, which in some sense we have touched a little bit upon in the questions, is how do you evaluate AI systems? And here I'm again using these games as an example. And then we'll go back to these Go games of 2016. And we all know that the computer won. But the interesting question is, how did the humans perceive the computer? And actually, there are a whole documentary around the human expert commentators commentating these games. And basically, there were several times during the matches where the human experts basically say, haha, the computer made a mistake. A human would never play like that. Meaning that objectively, this was a good move. Because, I mean, the computer won, so apparently it was a good move. It was objectively a good move. But from the human expert perspective, it looked like a bad move because it wasn't the way that we humans normally play this game. And now the interesting question becomes, I mean, this was just Go. So for most people, this is not super critical. But assume that this was a medical decision system. so that you have your highly skilled, highly qualified medical doctor, and it's getting this recommendation that here is the diagnosis or here is the proposed treatment. And from the human perspective, it looks completely off the charts. They cannot understand why should this be the appropriate treatment, because it doesn't match their experience. Now the interesting question becomes, should a human follow the recommendation or should it override the recommendation? Because there is no neutral choice. Both of them can go equally wrong. So it will not be an easy choice to make, but I really think this is a key question, because we can assume that the AI system has access to a vast amount more information than we do. But that doesn't mean that it's necessarily better than we are. But we're really going back to this question of how do we measure and how do we evaluate these systems? And I really think this would be a major challenge going forward. So what we see is that there are a number of issues related to this, and that's why I really think it's important to work with this trustworthy AI. So I have been part of this European Commission high-level expert group on AI, where we developed this ethical guidelines for trustworthy AI. So there we define that in order for an AI system to be trustworthy, it has to satisfy 3 principles. First of all, it needs to satisfy the rules and regulations that are applicable, so it has to be lawful. Secondly, it has to live up to 4 ethical principles. And last but not least, it also has to have a robust and safe implementation. So you actually have to build a system that really does this, and it's not just wishful thinking or good intentions. And the ethical principles that we defined were respect for human autonomy, meaning that these systems should augment, complement, and empower people. Second is that they should prevent harm. The third is that they should be fair, meaning they should have equal and just distribution of both benefits and costs. And the fourth is that they should be explicable, meaning that we should have an understanding of how they work. They should be transparent. It should be open with their capabilities. It should be able to provide kind of explanations and so on, so that we can understand why and how, or not how, but why and on what grounds or for whom it's making these recommendations. So I think this just the principles that we define. And now in the EU, there is now ongoing work in taking these recommendations and basically turning them into regulation. And it will be what is called a risk-based approach, basically looking at different applications. And if the application is considered to have unacceptable risk, for example, social credit scoring or subliminal manipulation. And a third is that, which is of course very much discussed, is what's called remote biometrical identification. So basically doing large scale identification of individuals, for example, in public spaces, for example, using face recognition. That all those would be examples of applications that could have unacceptable risks, and they should not be allowed. Then there is a class of high-risk applications, which basically I would argue is everything that involves people in some kind of serious or significant way. So, if it's related to, say, medical applications or recruitment or financial decisions and so on. These will then be considered high risk. And then there is a large set of substantial amount of regulation that you need to satisfy before you put this kind of application onto the market. And then the remaining categories are then low risk, where there's very minimal amount of restrictions on them. And the expectation here is, of course, that there will be very few applications with unacceptable risk, a manageable number of high-risk applications, and the majority of the applications will be minimal or no risk. My personal expectation here is that probably we'll see many, many more high-risk applications than anticipated, but we'll see. And if you then are considered to be a high-risk system, then, as I said, there is quite a number of requirements that you need to satisfy. But I would say that they kind of closely follow what we, or not close, but they're very much related to what we suggested in this ethical guidelines for trustworthy AI. One interesting aspect is that the regulation, this AI Act that's currently being negotiated, will not define everything in detail, but rather it will expect, or it will rely on standardization as a way for the kind of developers and the kind of ecosystem itself to agree upon what does this mean in practice, what are the best practices, how should you actually build systems that live up to these expectations. So this is just a list of all the ongoing, or not all, but the related ongoing standardization work regarding these different concepts. So this is something to keep track of. And I am coordinating Taylor, which is an EU network of research excellence centers, where we have the overarching goal of developing the scientific foundations for trustworthy AI. And that we believe that in order to do this, we need to integrate techniques coming from learning, optimization, and reasoning. We don't believe that any single technique will be able to solve all these problems, but it's rather through the combination that we will be able to do this. So the overarching vision is that we actually want to develop the scientific foundation for trustworthy AI so that we can help realize this European vision of human-centered trustworthy AI. And I think what's interesting is that we take kind of this approach that if you look at how human thinking seems to be working, at least if you ask people like Daniel Kahneman, then we have two different types of systems. The system 2, which is then called the slow system, which is then basically, I think the best characterization is as the kind of analytical problem-solving type of thinking. Probably the type of work that we do most of the day, where we have very explicit goals, we have very explicit processes of logically coming up with arguments for why things are. We're planning, we're doing all these kind of things, which is then very effortful, it's very deliberate, it's very conscious, and it's very controlled mental process. But on the other hand, and I would argue also this is kind of the traditional AI, has been very much focused in on how can we mechanize, how can we automate this type of reasoning, this kind of more logical and formal type of decision making. On the other hand, we also have this system 1, what's called the fast system. And here I think the best example is intuition. So if we're faced with a question or a problem, we intuitively often come up with a solution. And in many times, this solution is absolutely correct, but sometimes it's also completely off the charts, so it's completely wrong. This then corresponds to more unconscious, effortless, and automatic decision-making. And I think another very good example is object recognition. I mean, when we can see a little spot on the horizon, and we say, "Oh, this is probably my friend," or something like that. And I mean, quite often we are correct. I mean, even though it's very, very small, we still can guess who it is. So it's very clear that we have this other type of system, which we have very little introspection into. So we don't know exactly how, say, vision or intuition works. But and most of the time it works correctly, but sometimes it fails. And I would say this corresponds very much to this kind of data-driven, deep learning type of machine learning, which again often works very well, but sometimes also fails. And the interesting question is now, can we combine these two different types of systems into working unified systems? That is in some sense one of the goals that we have. And of course, there's a lot of details. But one of the things we have done is that we have developed a strategic research and innovation roadmap of trustworthy AI. So this was released, I think, a year ago. We have then also done a joint strategic research agenda between not only Taylor, but also the other similar types of research excellence networks. So now this was released in the summer, where we have identified a number of research challenges. In Taylor, we have a number of different research programs, but I will not go into the details in the sake of time. What I want to say is that we do have a handbook of trustworthy AI. So if you're interested in things like explainable AI, safety and robustness, sustainability, respect for privacy, and so on, there is an online handbook where you can learn more about these things. And of course, we have done a lot of research in many of these different areas. So the last couple of seconds, maybe I should say something about the relation of AI and work. So, I mean, there came a number of reports a number of years back stating that 50% of all the jobs will be automated. I think that's not the case because the reason is that what's automated is not kind of jobs, but activities or tasks that we do at work. And if you look at the different types of work, there is a different number of activities that can be automated. So I think in reality, what we will see is that, say, maybe 30 to 60% of the activities that we do at work can be automated, and of course then will be automated. So the consequence of this is that rather than 50% of the jobs being automated, what we will see is that almost every job will be affected. So I will expect that most jobs will change, and that most jobs will have quite a substantial amount of automation, helping us to do the work more better. And there are some initial studies showing that if you use these kind of tools, you're quicker to become productive, and you actually become more productive by using this kind of AI tools compared to not doing it. So what do you need to succeed? I really think we need to focus on the combinations of AI and humans. I think we need to focus much more on education because, I mean, we need to learn much more. And we also need to work in ecosystems. So I don't think any company or organization will be able to deal with all of these things on their own, but rather we need to open up our systems. So what we see is that the first step is basically an organization becoming data-driven. So you get the data flowing within your organization. The next step is you start exporting your data outside of your organization. The third step is that now you import the refined and improved and elaborated information. I mean, you shared your data, and then you took the improved kind of end result of third parties applying their work on their data to your system again, or your organization again. So you get this external feedback. Then you really are connected to the ecosystem. So to conclude, I think, first of all, I mean, what we're seeing is really this, that by using AI, people become better at doing their jobs. So we're seeing a number of different studies showing that on a wide range of different tasks, people become better, do their work better with higher quality, and of course also faster, so more quantitative, by using these tools. So I think, again, we're really getting back to this fact that it's about people using AI. That's really the key. So to conclude, AI is here now, but the development is also very rapid. We see impressive progress in these large language models, for example. I think AI will affect all aspects of society, and that this data infrastructure and leadership is necessary for organizations to effectively take advantage of this technology. But the technology should also be human-centered and trustworthy so that we actually feel confident and comfortable in using it. Because in the end, it's not a question of either AI or people, but it's really a question of AI and people together. And together, we will be able to deal with all the challenging problems that we are facing, and we can improve the capacity and the capability of our organizations to do their work as well as possible. Thank you very much.
Now I'll make sure that you hear me.
Yes, I hear you now.
Okay.
Yes.
And sorry about the miscommunication that we had here. In my schedule, we were supposed to have a discussion session, but I think that wasn't clear on your side, but that's fine. I think we have time for one last question. Anyone? No? So I think you were pretty clear. Thank you very much, Frederick. And now let's thank him again.
Thank you very much.
People were asking if they are going to have access to the slides.
I can
afterwards.
send them to you, yes.
Okay, so afterwards you send us, and then we interact here with the organization team to give this. Okay, so thank you very much.
Thank you. Bye-bye.
Thank you, Professor.